Şimdiki sunumumuz Doktor Ali Amiri tarafından verilecek. Doktor Ali Amiri, University College London'dan inşaat mühendisliği ve sürdürülebilirlik alanında doktora derecesine sahiptir. Rambol, Orta Doğu ve Asya Pasifik'te sürdürülebilirlik başkanıdır ve özellikle inşaat, ana planlama ve altyapı projeleriyle ilgili sürdürülebilirlik ve yönetim alanında inşaat sektöründe yaklaşık 20 yıllık bir deneyime sahiptir. Doktor Ali, kariyeri boyunca Birleşik Krallık, Birleşik Arap Emirlikleri, Suudi Arabistan Krallığı ve Katar gibi birçok ülkede çalışmıştır. Binaların ve inşaat mühendisliği projelerinin sürdürülebilirlik değerlendirmesi hakkında birçok makale yayınlamıştır. Buyurunuz.
Thank you very much. It's not easy for a civil engineer to do a presentation after an architect. No. Normally we do a lot of presentations for decision makers, government bodies, clients and politicians. But it's a pleasure to do a presentation to an audience that will actually do some work. Today I thought that I just do a quick review of some of those buzzwords that we hear. A lot of them was covered in the earlier presentation. And I thought just to touch on one of the recent terms that you probably have heard of about circular economy and what does it mean for us. Before that, I got a few questions today about Rambol, so I'll do a quick introduction on Rambol, who we are. It's an independent engineering and design consultancy, founded in 1945 for a few hundred, and now we are more than 15,000 experts around the world, with annual revenue of more than 1.5 billion euros. And it's a foundation establishment, so it's not fully a 100% commercially minded corporate. We do a wide range of holistic analysis and multidisciplinary engineering, and we provide world-class technical consultancy and expertise from design, process management to management consultancy. And throughout the years, the company kind of is widely spread around the world, with a strong presence in Europe, North America, and Middle East and Asia Pacific, where I'm heading its Department for Sustainability. And this is the revenue and profit for each of the markets that it has. I just wanted to talk a little bit about why sustainability and the fact that it's not just about saving the planet. As also again mentioned in the earlier presentation, these days we spend 90% of our times in an indoor environment. And if we do not design for a healthy indoor environment, we could be exposing it 2 to 5 times more pollutants than outdoors when we're inside, from the VOC contents and level of ventilation, air quality that we get from indoors environment. And both investors and end users are becoming more and more educated and aware of these facts. So you can see that there is a trend in market. I was doing a conference doing a talk in a conference yesterday in Finland, and tomorrow I'm flying to Copenhagen again for another conference. And in these Scandinavian and Nordic countries, which is the home to Rambol, you can see that there's a trend in the market towards green buildings. And in those markets, those buildings that are not designed based on principles of sustainability, they're called brown discounts, where those buildings go as a lower premium than a green building or green certified building. So you can see that the market is becoming more and more aware of these increasing sales and increasing production and increasing health and well-being of utilizing different typologies of buildings, be it hospitals. In the States, for example, federal states, they save hundreds and millions of dollars a year by upgrading the hospitals to better indoor air quality and indoor environmental standards, and the turnover of the patients and savings on insurance and saving on health costs is reducing. So there is an actual hard saving on improving the buildings into green buildings and sustainable buildings. Generally, there is this perception that building to sustainability requirements could immediately increase the initial cost of the construction, but this is actually just a perception. As we progress towards more and more strict requirements from the local municipality and green building requirements, you can see that capital cost is dropping, and currently it almost costs nothing to build into LEED silver requirements or LEED gold. It's 0 to 2% of your construction budget increase. So whenever we get this immediate pushback from our clients that, oh, why should I go to, for example, LEED gold, we, within Ramble, in our design team, we kind of guarantee to them that no, even if in employee requirements they ask for LEED silver, we guarantee to them that, look, we can achieve through value engineering. Let's aim for the next level, because it will put you in a better situation in the market, and it will improve your return of investment within a reasonable period of 3 to 5 years. So even if you spend a little more, you will gain it back. So this perception is changing, and I was really impressed to see that an end user was willing to pay for a one-bedroom house to achieve a LEED Platinum. That's really promising, and we're hoping that then the market and the wider market goes through the same understanding and showing the same level of interest. The only other thing is that we need to be aware of that whatever we do in our design to design the most sustainable and perfect building, it always comes down to the end user and how you use that building and how you commission that building. So especially for Ramble, when we're dealing with kind of bigger developments, we end up with a community of end users. We always have to make sure that during the handover, we provide them with a good commissioning process and standard and effective management and collaboration between the owners and the occupiers and tenants, so that they actually commission and use these buildings in a manner that is responsible. The other thing is when we design the buildings, we always have to bear in mind the life cycle aspect of our building. Again, in the earlier presentation, it was touched on the embodied energy and embodied carbon, which is very important, and it was a very hot topic. I think last week in New York, World Green Building Council, they issued this net zero carbon roadmap, which had a big emphasis on the embodied carbon. As mentioned, the embodied carbon is all the carbon that is spent on coring the material, manufacturing them, transporting them to the construction site, and the carbon that is spent, energy is spent, and carbon that is emitted on the construction site to get the building built. And then year on year, you will have on your carbon footprint of your building, you will have the operational carbon. And I understand, and it's correct, to emphasize on the use of local materials to reduce the transport impact of your embodied carbon. However, we need to be mindful of the life cycle of the building. For example, this is just an indicative scenario of life cycle of a building, where you can start with your, if you assume that this is your embodied carbon or embodied energy, where you spend the carbon to get your building built. And let's say that it was all the local materials and very low embodied carbon, all good and well. And this will be the behavior of the building. The steps that you can see on the maintenance intervals in a life cycle of 100 years of the building, let's say typically in Europe. But what if we do actually use a material that is coming from, let's say, further away, hence our transport carbon, which is always relatively much less than the carbon embedded in the manufacturing of the material. You spend a little bit more on the embodied carbon to use good quality materials and good envelope for your building that has a better performance in terms of operational energy of the building. So you spend a bit 10% more on your carbon footprint, but then what if the end result could be like this, that it's more durable, it has a better operational energy and operational carbon behavior throughout the life cycle of the building. So when you have a life cycle vision, you can see that, okay, maybe what if we spend a little bit more on embodied right up front, we might save a lot throughout the life cycle of the building. It will be perfect if we can even avoid that bit, but we should be open to consideration of the life cycle behavior of the building. So that's one thing that we should bear in mind. The other aspect for investors, for bodies such as this Chamber of Civil Engineers here in Cyprus, is to be mindful of these visions and requirements. On this one, I have all the national visions that, for example, UAE has got for each of its emirates. So what they have done is that this United Nations Sustainable Development Goals, they try to consider all 17 goals and the KPIs under each of these goals, and they try to define and prioritize what do they mean for each of these emirates within the country, and how to actually translate this from a macro kind of high-level policy making into a micro-level coding and improving the standards and codes and requirements, so that they are, when United Nations is gradually putting pressure on countries and governments to implement these SDG requirements, they are prepared for it. And I hope that here in Cyprus, you guys either have done it or you should start looking into this aspect, that what are the SDGs, the 17 criteria, what do they mean for us, what do they mean for Cyprus, and which of these 17s are the priority for the country. And be prepared for it, because it's coming and it will be implemented to each of the governments across the world, and everybody is kind of now trying to voluntarily produce a national report every year or every other year to report on their progress on the SDGs. The other aspect is that climate change. I know some politicians in the world, some of the strong ones, do not believe in it, but scientists and engineers, it's almost a common consensus that climate is changing. It's not about mitigating it anymore, it is changing, and we need to be ready, and we need to be prepared for it. I saw some shocking facts from World Economic Forums the other year that by 2030 or 2050, I think that a majority of the ice in the north gets melted throughout the summer, and then before it gets formed again during the winter. So that could have a significant impact on sea level rise aspects, and for a country like here that you're just living by the coast, you need to be mindful of these changes coming, and also it becomes a serious commercial matter for insurers. We were doing a development in Jeddah, Cornish, and the insurance company wanted to see our analysis and our resilience report for climate change and sea level rise, because they wanted to know that what is the cost of insuring a development on the verge of the sea, and whether or not we allowed for climate change adaptation. Another project that in Abu Dhabi we had on Reem Island, again, the client, the investor, wanted us to design for a 1 in 100 years storm event from the storm from the sea and sea level rise. So I think these are the kind of things that we hear it in the news, we hear it in from politicians, but when it comes to actually do something about it, is you guys, is the civil engineers, is the architects, as you see in the earlier presentation, that you are the actual, and we are the actual people who go to the ground and implement these concepts and requirements. This graph, I like it because this is just, I was discussing with friends earlier, the difference between sustainability and the structural engineering, for example, is that it's evolving all the time. Like we are constantly faced with challenges, and we overcome a challenge, and something else comes in. For years, we were involved with operational energy, the ASHRAE standards, and it worked. I mean, we paid attention to it, and now our buildings, the operational life and operational energy of the buildings is becoming more and more reasonable, and the embodied carbon and the carbon that is spent to get the building built is becoming more of importance because the operational profile is going lower, so embodied is becoming more apparent and making a bigger chunk of the life cycle of the building as well. So we worked on that, and then we got into the life cycle cost, that we realized that, okay, we build our buildings, we build our bridges, but we need to think about their durability, because at times it costs more to maintain that asset. In UK, for example, they had for years that they were building their bridges out of concrete. They thought the concrete just lasts for 100 years, nothing happens to it. Then they realized that during the winter, they put the salt to prevent from the ice forming and to melt the ice. Then the salt gets into the concrete. It corrodes the rebar. The concrete collapses, and then they have to go back and maintain. For that, they have to restrict the traffic. The traffic is congested. Emissions goes higher. The cost of the traffic. So life cycle costing was something that after a while we realized we need to think about the life cycle of our building and the cost that comes later on. We worked on that, and we have methodologies for it. We have whole life cost analysis methodologies, and we're working on that as we're considering that in our design. Then we got to the concept of circular economy, which I'm going to speak about it very quickly after this one, where we're trying to close the loop, to change our linear behavior from extracting the raw material and then dumping it away. Again, a nice slide in the previous presentation was that, where does this waste go? Where do we throw it away? There is no away. Everything remains. We have to find a use for it. Yesterday in Helsinki, we had another architect which has done a very inspiring presentation, that how they go and try to demolish that he tried to make upcycling every materials that he could reuse from demolish of existing buildings. One of the things that he was struggling were actually the bricks. So the facade was made of bricks. He realized they cannot use it as a structural element. So he tried to cut them in a bigger panels of like a facade panels, and then he made a nice pattern out of it. He used AI technology to come up with a beautiful pattern for it. And you could see that they are, again, us civil engineers, architects, we are getting into trying to understand circular economy and how we can actually implement it. Otherwise, we can always wait for decision makers and politicians just talk about it, but again, it comes down to us to actually implement it. And the next thing is that, as I discussed earlier, climate adaptation. Climate is changing, and we need to be able to adapt for it, and we need to learn more, and we need to invest more in training and knowledge about climate adaptation. And then the next stage is to social quality and livability of our buildings, livability of our outdoor environment. How can we maximize use of outdoor? How can we maximize use of pedestrian-friendly developments and urban systems, so that we can minimize the dependencies on cars? And of course, as I said, SDG certification. At the moment, we have LEED, BREEAM. In UAE, we have Estidama or Green Star or DGDR, but we believe that SDGs, Sustainable Development Goals defined by United Nations, it's kind of working, and it's kind of becoming as a consensus, as a global consensus for how to define sustainable development in each of the countries around the world. So maybe very soon we will face with SDG certification. So we should educate ourselves and be prepared for the SDG certification schemes that are coming. Yes, circular economy, I thought that maybe just a quick recap on circular economy, what does it mean for us? The principles are there, so it's not a totally new concept, it's just that the attention is more focused on it. As I said, we are realizing that, okay, we need to close this loop. We cannot just consume and then landfill. This is not working, this is not sustainable, we need to close this loop. And therefore, the principles that are being studied and being implemented in our designs are to right at the beginning to decide to how to design out waste, how to design for resource efficiency and design for deconstruction and disassembly. We designed this football stadium in Doha for the 2022 World Cup. Of course, as per the FIFA requirement, it has to be a 40,000, 45,000 seats, but Doha doesn't need a stadium for 10 stadiums, each 45,000. They don't even, the entire population of Qatar is 800,000. So what we came up with is that after the World Cup, the 25,000 of the seats are disassembled. The structure, the supporting terraces and the seats, the structure is is deconstructible. It will be disassembled and reassembled in a country in Africa. So they're donating that structure to rebuild and reconstruct a smaller stadium out of those structures in Africa. Of course, to maximize the use of renewable energy is another principle of circular economy, reducing the embodied carbon over the whole life of the building. Embodied carbon is at the beginning and also throughout the building where you do your maintenance, when you need to do improvement to your facade, to the envelope of your building. Normally, superstructure and substructure don't need major maintenance during the life cycle of building, but the other elements, the finishes, they do need that, and we do need to account for that during the life cycle assessment of the building. Yes, and as again was discussed earlier, you have to have all this strategy right from the beginning so that your concept is built upon these directions rather than getting. Sometimes what we see is that for lead, silver, gold, platinum, or barium, very good, excellent, what happens is that these tools are being used as a checklist for measuring an end product. They come right at the end of the, for example, as concept of SD or DD, they come in and say, okay, so have you done this? Yes, no, yes, no. Then at that stage, it will be very late to go back and consider what could have been done. These tools, these principles of sustainable development design, it should be embedded right from the beginning, right from the concept. You should have your tracker of what are the credits that you want to target, what are the principles you want to incorporate in the design, and have iterative workshops with your sustainability team. And or if you yourselves are educated enough to go through the credits, have them in mind whenever you're reviewing your design. Collaboration with supply chain is key, absolutely, that's true, because whatever we do, whatever we try to reduce our embodied carbon, to reduce our carbon footprint, the question earlier from the lady about the concrete was that, was it at the end, was it concrete? You can use local aggregate, you can do whatever you want, but still cement is there. And I think, as a member of construction industry, I'm a bit embarrassed about this cement issue, because look at what the IT guys achieved throughout the years. Look at the medics and their sectors. Construction, how many years? It's been hundreds of years we're using cement. I think it's time to talk to our supply chain, to the material manufacturers, try to work together to see how we can just move on from this cement. And because whatever we do, we end up using cement and steel, and the carbon is there. World Green Building Council set up a strategy that by 2030 to cut the carbon by 40% and to achieve net zero by 2050. But to achieve a zero carbon, to achieve a zero impact on our climate, we really need to do something about our carbon footprint. And for that, we need to rethink material. And we need to, I know that it's coming with the nanomaterials. They're trying to come up with the materials that actually harvest carbon and absorb carbon back to the structure of the building. But that's something that we need to bear in mind on material selection. And use of local materials is a great help. It reduces the transport carbon, the use of the local stones as we saw in the earlier presentation. But concrete is still there, and cement is still there, and we need to do something about it. We do, as was mentioned, we do try to maximize cement replacement by whatever byproducts are available, be it GGBS, PFA, but still we need to go further. And yes, have iterative workshops, as I said, like try to go back to design and see what else can we do. Try to push the boundaries and don't just stick to the agreed target of whether it's lead silver or lead gold or BREEAM, etc. What McKinsey has done, they have developed a framework for transition towards circular economy. They try to kind of, as they are management consultant, try to make it very systematic. So they divided the principles of circular economy into these 6 categories of regenerating, sharing, optimizing, looping, virtualizing, and exchanging. What I tried to do was to adopt McKinsey's approach and highlight items that, what do they mean to us as civil engineers, and what does it mean to our sector. For example, on the regenerates, we can shift towards renewable energy, renewable materials, reclaim and retain and restore health of our ecosystems. With, like, again, in the earlier presentation, I really enjoyed to see that we tried to adapt to the location of the trees, so with the minimal impact to the existing ecosystem, to reduce our embodied energy and carbon. To share is to prolong the life of our assets, buildings or roads and bridges, through maintenance, design for durability and upgradability. Yesterday in Finland, there was a presentation, an interesting idea about the concept that why don't we just lease, for example, for this building, lease the carpet from the manufacturer rather than buying it. So that the manufacturer will be in charge of applying the carpet, and we're paying an annual rent to them, so they will have to, and whenever we don't want it, they can come and take it back, making the good for and reuse it on another project. Maybe we should think about that, reusability of material through a leasing scheme, like have a different commercial approach to the ownership of materials. Optimizing, of course, remove waste in the production supply chain, decrease resource usage. I think optimization is an easy one because you don't get any pushback from clients. They always want you to do value engineering. They always want you to reduce the depth of the beams wherever you can. They always want you to reduce the thickness of your core walls as you go through a high-rise tower. They always want to reduce the strength of your concrete where needed, hence you can reduce your cement-water ratio. Therefore, and it's good for us because then it's reduced our carbon footprint. So optimize is an easy one because it saves money to everyone, or immediately saves to everyone. We have to try to loop, so upcycling and recycling materials, and prioritizing circular materials where we can, use waste where we can, and try to close the loop so they don't end up in the landfills. One of the interesting things that this architect presented yesterday was that they tried to create an exhibition of waste materials, but they tried to segregate them and pile them together. Their idea was that when you do that, all these bottle caps, for example, all these plastic bottle caps, when you put them all into a depot of that, and then you depot of cans, and then when you look at them, it inspires your thought that what can I do with this? You don't look at it as a waste because there's a pattern there, and you can. It helps to think about. It gives you ideas on how to make some use of it. It was he had these transparent tubes of glass tubes that he put all the, for example, wine bottle heads in them. They had the plastic caps in them, and he created an exhibition out of them. And they had a competition for children to come in and say what we can do with this, what we can do with that. So really treating waste as a resource and what can we do with it. And he had this idea with the cans that he created a facade for one of his projects. So he reused all the waste cans as an aluminium facade of his building. So he didn't have to go to China. He could actually use the waste that was available in that little town. Virtualize, of course. We should move to, it's a pleasure to be here. It's a beautiful seaside, but we should move towards virtual meetings, virtual conferences, where I can present this over a video conference with the same quality, and hence reducing my carbon footprint. I'm really embarrassed this month with my carbon footprint. I've been from Dubai to Finland to Cyprus, I'm going to Denmark, from Denmark I'm going somewhere else, going back to Dubai, and then yet I'm talking about sustainability. So I'm probably, this we need to cut down. I mean, this is already we're cutting down. I'll show you an example later on that we designed a project in Abu Dhabi with an architect firm's BIG in Denmark, and then BRDV in Rotterdam, and all the meetings were through video conferences. Like, I traveled only maybe twice to Rotterdam just for the initial coordination. Other than that, everything was done through video conference, so I'm not that bad. And of course, exchanges, yes, replace all the advanced renewable materials and apply new technologies such as 3D printing. 3D printing, nanotechnology, and AI will change our future. So all these things that we're discussing, we don't know what we are up against with when AI and 3D printing actually kick in and dominate the market. They might actually make life much easier for us. And AI could decide for us that, no, you're better off with designing for a timber structure here, because timber has lower embodied carbon, hence on knock-on effect on all these other material requirements. This is my last slide. This is one of the projects I was just telling you about. This is, I just wanted to show one example where we try to comply with the SDDAMA requirements, which is the equivalent of BREEAM and LEED for UAE. And in addition to that, we try to go further and provide better access to public transport. So for this project, it's a Pixel. It's called Pixel. It's designed by MVRDV. The public realm carries on to the promenade and the public realm, and two other plots adjacent to this one are designed by BIG architects. So here what we try to do, these towers, Pixel towers, are 7 towers that go up from 15th floor all the way to 30th floor, mid-rise tower, and come back to 17 floors. The concept is that the towers are like pixelated from the top and kind of distributed on the bottom. A very complex structure because you had a lot of discontinuities on the structural elements, so we had to incorporate a lot of transfer structures, a lot of discontinuities on the MEP shafts and risers. And what we tried to do is that typically UAE and Dubai is very dominant by cars, and it's this general culture of driving fancy cars and prioritizing vehicles over pedestrians. So in this development called Makers District in Abu Dhabi and Rim Island, we try to work with these architects to actually promote a culture of outdoor, maximizing use of outdoor by providing public a lot of passive design to the towers so that they provide shading to the wadi that is running in between the towers, and providing a vegetation using the native plants in the region, and using a lot of the condensate water from the towers as an irrigation source for the water, so using no potable water to irrigate the entire landscaping. I know what you're thinking. There's again a lot of concrete, but this is the nature of the economy. The development will be there. There will be, the economy requires the buildings, but what we can do when we go in, we try to at least implement these principles of sustainable development. We provided a smart system for recycling waste, so tri-sorters on the bottom of the chutes will realize which one is plastics and which one is paper and which one is general waste, so it segregates waste at source. And yes, and this is the project that I told you about, that we had 2 teams of architects in Copenhagen and a team of architects in Rotterdam, a team of interior designers in Barcelona, landscape architects from Dubai and Australia, but all the meetings were VC conference meetings, and the project was finalized. It's achieved its building permits, and the main contractor is mobilized. And we have a lot of other projects that the CAPSAC, which is LEED Platinum, DUCA, which is a LEED Gold, and but I don't want to go through too many of them. Just wanted to have a general recap on some of these sustainability terminologies that we need to be mindful of, because the regulations are coming and the challenges are coming from the government and United Nations requirements and the national visions, so we need to be prepared for them. I think that's about it. Yes. Thank you. Questions? Yes. I think you do need a microphone back there.
Hello, and thank you very much for your nice presentation. Me as an architect, I have a question to you about, because my expertise in heritage conservation. I would like to know your idea about applying sustainability in heritage conservation and heritage buildings, or adaptive reuse of heritage buildings. I would like to know how you can apply sustainability in such a buildings.
When we talk about sustainability, I didn't go to the textbook definition of sustainable development, which is social, economic, environmental. We definitely have to be mindful of the social aspect of sustainability. And definitely one important aspect of that is to preserve our cultural heritage and cultural buildings. But that's a good point that brings something that maybe I should have added to my presentation, is we are not just dealing with new constructions and new buildings. A lot of time it's about how to, again in line with principles of circular economy, it's about how to maintain and upgrade our existing assets, be it a cultural building. And our UK team, we have a dedicated department. They have their own structure engineers, their own MEP engineers, and their own sustainability engineers that are dedicated only to, and we have an archaeologist team that are only dedicated to historic buildings, and they're looking at ways of preserving them. And even there, when we are looking at preserving these buildings, we look into options of how to minimize the use of high carbon material and how to maximize use of low carbon materials, where we can protect the building by use of timber, by use of locally available materials like bamboos that we saw in the earlier presentations. So that you can still, it's a must, I'm sure it's the same here, maybe less in UAE, but in Europe we have a lot of such cases that we have to preserve historic buildings and cultural values, because it is in line with the SDG social KPIs of the SDGs, and also in line with the social pillar of sustainable development. But in addition to historic buildings, also to do with a lot of existing buildings, how we can do we actually, in a lot of countries, do we actually need that many new constructions? Like in London, there's so many beautiful buildings out there that are just not fit for the current purpose that they're serving. How we can retain those buildings and make them adaptable and flexible in their use and in their design, so that if it's a tall office building, but during the financial meltdown, there aren't many businesses to rent that, how can we design for flexibility that we can make the use of the same building convert it into residential without knocking it down and building new? So refurbing and preserving the existing building even more important, historic building, I think, is an important factor and it's in line with the principles of sustainable development. But we need to be mindful of the similar things on embodied carbon, and if we can, there are opportunities to reuse material, to respect the culture of the building. You don't want to have a historic building, but then provide the strengthening with the ugly looks of reinforced concrete. Perhaps you need to look into options that your architects are showing comment on this, but to preserve the characteristics and identity of the building. I don't know if that answers the question.
Yes, thank you very much.
Good, thanks.
You mentioned there's an office in Cyprus.
Bramble office?
Yes.
Perhaps, yeah. Was it my
It was in the
slides?
presentation, there's an office in Cyprus. So. How big is it?
Oh yes, that's from our environmental and health team. I think it's a small office, but we do have presence here.
Okay.
Because a lot of these are the recent takeovers of Rambo that we took over a company called Environ that had offices in various countries. I'm pleased to see that. Sorry, thanks for your note. But I'm sure it's environmental health. And from the conversation earlier, I understood that we need to sign off a structural design. We need to have a local authorized signatory to be able to build. We'll work on that. Any other questions? Sure.
Thank you very much for your nice presentation. I have one question regarding the material point of view. Can you hear me?
Yes, I think that the plan was that you guys hear me. I cannot hear you.
So my question is that you said that the concrete is an inevitable material that we cannot do anything. I'm going to ask you, are you giving any suggestion in terms of using the concrete with lower contamination? For example, nowadays, you know that for the concrete production, we can use a material replacement. We can use some pozzolan material, some waste material as a cement replacement. Are you going to suggest the constructor to use such a material?
To replace the cement?
Yes.
Yes, it is. That is kind of common practice now, to replace cement content of concrete up to, depending on the grade that you're aiming for, up to, I think, 70% in some cases, 70-80%. Also, we have, Dr. Abdullah mentioned earlier about the additives. We have plasticizers and super plasticizers where we add to the concrete mix, where they help with the flow of the concrete. Hence, you don't need that much water, so you can reduce the water content of your concrete. Hence, you can reduce the cement content of your concrete, because if you need a cement-water ratio of, for example, 40%, and by use of a lot of that water is not needed for the strength of the concrete, it's needed for the flowability of the concrete. So when you apply these plasticizers and super plasticizers, you can reduce that water content. Hence, you can reduce the cement content, and then the rest of the remaining cement, as much as you can, you can replace it with byproducts such as GGBS and fly ash, and the sort of one that you said is available locally. So there are techniques, and structural engineers, civil engineers, they are looking into those. But still, you need to be mindful that when you are going towards these chemical products, you need to be mindful that what is the carbon footprint of that product, and what is the impact that manufacturing line of that product is having on the environment. But overall, I think the research suggests that whatever that results in reducing the cement content still helps on the overall carbon footprint of the concrete. The other thing that you can do is, we discussed embodied carbon. there are libraries and datas for carbon conversion factors of main construction materials. For example, for concrete, different grades of concrete, C45, C35, C50, whatever, they come up with a kilogram CO2e per kilogram of that material. CO2e means CO2 equivalent, because global warming potential of different gases varies, but we mention everything in the unit of CO2. So each of your construction materials, be it steel, be it concrete, be it glass, be it aluminium, asphalt, aggregates, every one of them, you have a card, is publicly available. It varies slightly from one country to another, but you have a kilogram CO2 per kilogram of that material. One way is for when we are doing our Revit models, when we are building our model in BIM and Revit, we have these libraries of information about each of these materials. And that's how the cost consultants, they extract their cost sheet out of their Revit model, right? We can include, at least for major materials, not every single carpet tile or every single socket on the wall, but at least for major materials, steel and concrete, and aluminium and glass, they make 90% of the carbon footprint of our buildings. Even if we only focus on these major materials, in our Revit models, we can add a library of information. What is the carbon footprint per kilogram of this material? So the structural engineer, they don't need to go to sustainability, they don't need to do a sustainability PhD to know how to reduce the carbon footprint. They become mindful that as they build up their Revit model, they can say, oh, my cost is building up, and also my carbon footprint. So maybe I can minimize the depth of my beam. Maybe I can minimize the core thickness of my core wall. Or maybe, do I actually need a C50 grade concrete in my tower all the way to the last floor? And that floor we used an algorithm to see from which floor upwards we can reduce the cement content gradually. And hence we reported the carbon footprint of our structure. So there are easy wins that when you say that, oh, 20% save on my carbon footprint of my design, it might come as a shock that how do we do that? But you can easily play with your model and you see that actually I did save that. And the results could be fun. You don't have to report your carbon saving in like 380 kilogram of CO2 and then everybody, okay, what the hell is that? But then you can say that, okay, every travel in an average family car is like 0.2 kilogram of CO2 per kilometer. So if I save 300 kilogram of CO2 in my singular story building, it's like I'm saving 5,000 of travel in a very polluting car every year. So if we do these simple exercises that you don't need a huge investment in Cyprus, for example, for your engineers, that guys, how can we, when we're doing our Revit model, be mindful of our carbon footprint and then report out on our savings as an achievement of this exercise. And so, sorry, yes, we are looking into options of reducing cement replacement, but in addition to that, how we can optimize our design to overall reduce our carbon footprint whilst waiting for the material scientists to come up with a replacement for cement.
So you mean that you are applying, you are suggesting this to the constructor as a one option or one parameter?
We are the designers, so we put the specifications there for the contractor to build like that, as per that. So we say that we want here a C45 concrete, and this is the mixed design that we expect. Sometimes contractors could push back if it's costly for them. Sometimes they push back because it's difficult, they'd rather add more water and the concrete is easier to handle and just move on. But as designers, we specify a low carbon and optimized design, and then on big projects like this, the contractor will have to follow because we have also site supervision, and so we make sure that design is actually followed as far as possible. So yeah, it's part of our design requirements.
Thank you so much.
Thank you. Any other question? Thank you, and sorry I talked a lot. Thank you.